This is Arduino-based miniature forklift simulator created in Unity. I made the hardware communicate with the Unity using a microcontroller and Arduino board. But how does it work? And what exactly is Arduino? Let's find out. This is Arduino, an open source microcontroller board. This is the kind of devices are used in 6DOF motion platforms and simulators. This microcontroller works as a communicator between your hardware, that is the motion simulator, and your software that's running on the computer. In this case, it's a racing game. This is ESP8266 model, which works wirelessly. But to make a forklift simulator, I at least need two analog inputs. And if you look closer, this model only has one analog input, A0. So I had to buy Arduino. Then this is a breadboard, a temporary work surface used for building electronic circuits. These are jumper wires with connector pins on each end to make connections without soldering. Let's connect the jumper wires to breadboard. The whole project with instructions and the circuit diagram is available on my GitHub, so you don't have to worry about where I'm making connections. Because this is gonna look mess anyways. Optionally, you can support me on Patreon, link below. Long story short, the analog inputs of the Arduino A0 and A1 are reserved for potentiometer, A0 for steering and A1 for forks control, and 3 digital pins for buttons that will be for acceleration, reverse acceleration and brake. This is a miniature simulator. I made it out of cardboard and painted it black with acrylic colors. I fitted 2 potentiometers inside this. This one for steering the forklift. Let's connect the steering, which also is made out of cardboard and toothpicks. This handle for raising and lowering the forks. 3 buttons for forward, backward and stop. I use these digital buttons which just gives binary value. Now let's connect the potentiometer and buttons with Arduino. Steering, forward button, backward button and stop button. Then forks handle. This is the Arduino USB connector. Let's connect it to computer, then to Arduino. And now it's on. Launch the Arduino IDE app. Compile and upload the code and we're ready. Launch Unity and play. And this works. You can steer the forklift, raise up and down the forks and drive. I have included 4 levers in this prototype where you maneuver picking up the material and placing it on the marked area. Sometimes on the ground level or sometimes on the rack, raising the level. There are a free roam level where there are multiple boxes to pick and place, but with more precision. When placed correctly, they lock in place. Let's have a look at how communication works. To send and receive the data from the Arduino module to your software, you have to make a connection through the serial ports. If you open any level, select the forklift model and open the script forklift controller attached to it, scroll down a bit, and this is the part where the communication variables are established. Most important are port name, a baud rate, which are public, so we can edit it from the inspector. For the port name, you can change it to COM1, 2, 3 or 4 based on which port your Arduino device is connected. So let's check it where it connected. Open the Arduino IDE software. This is where you write code for Arduino. You can download it through the link in the description or from the instructions that are included with the project file. Here at the top left corner, drop down, this is where you can find which port your module is connected. So let's connect the module, and here it is. Seems like it's connected to COM3. Let's change it to COM3 in Unity. Baud rate is another thing that is defined in your Arduino code in the setup section, but for now, just make sure it matches in Unity. Data is defined into Arduino code, so here the potentiometers and buttons variables are defined. The pins A0 and A1 being the analog inputs and pin 2, 3 and 4 being the digital inputs, which can be easily found on your microcontroller. You can modify them if you wish to change the pin connections, but for potentiometer connection must be analog. Down here we simply print values, which are in range from 0 to 1023 for potentiometers and binary 0 and 1 for the buttons. In the forklift controller, scroll down to the read serial data section. This is where the values are passed from serial port we defined earlier. As we know, the potentiometer gives value from 0 to 1023 in real time, so we somehow need to convert them for our use case. This is where the map function comes in. It does a little calculation where I can map the value 0 to 1023 to minus max steering angle and plus max steering angle as the rotation angle for steering, which is 30. If you select the fork game object, open the script forks controller attached to it. Here I define min port value and max port value. This solely depends on the orientation of your potentiometer. For me, this value works. It could be different for you. Here I just say that when the potentiometer value is greater than 175, then raise the forks, and when the value is less than 75, then lower the forks. That's it. From now on, whenever you connect your Arduino to the USB port, it's gonna work like a magic. Feel free to break down the code, experiment, and swap connections to customize your Forklift Simulator. The source code for both Unity and Arduino is available on my GitHub and Patreon, along with templates like Mario VR game and AR shooter game. If you got any questions, drop them in the comments or connect with me on Discord. And if you found this helpful or enjoyed it, give it a like and subscribe. Have a great day and I'll see you in the next one. Also, a big thank you for the support from the following Patreon members: